Today we're going to talk about how to classify functions. We'll need to make sure we're as specific as possible with our classification, without forgetting to classify the entire function instead of just a piece of it. In this particular problem, we've been asked to classify each of the following functions: f, g, h, r, s, and t. And over here on the right, we've made a list of the most common types of functions. It's not a comprehensive list, but it's a great start and it'll be enough to get us through this problem. When we're classifying functions, we want to be as specific as we can. For example, if we can, it would be better to say that a function is a trigonometric function as opposed to just being able to identify it as a transcendental function. In the same way, it's always better if we can provide more information about a polynomial function by describing its degree as quadratic, cubic, or some other higher degree polynomial. Over here on the other side, we need to make sure that we're classifying the whole function. So for example, with our function f of x, you might be tempted to just look and see what's inside of our square root and think to yourself that x could just be a polynomial function, or it could just be a power function. And both of the things would be true if f of x just equaled x. But the entire function is actually the fifth root of x, which is also the same as x to the 1/5 power. X to the 1/5 is still a power function because any function in the form x to the a, where a is a constant, is a power function. But if we don't have to, we don't want to stop at calling this a power function if we can call it either a root function or a reciprocal function, which would be a more specific description than just calling it a power function. And in fact, because our exponent is 1 over a constant, 1 over 5, we can call this a root function. Our function g of x is similar in the sense that we're still dealing with a square root sign. If we just look at what's inside the square root, we can see that 1 minus x squared is a polynomial function because our exponents here are non-negative integers. We could also get more specific and call this a quadratic function because the degree of our polynomial is 2. But if we did that, we'd be ignoring the square root sign. We know that this is the same thing as the quantity 1 minus x squared to the 1/2 power. And you might be tempted to say, well, then that's a power function because we have this exponent here as 1/2, and maybe that's even a root function. But power functions and root functions only apply when your base is simply x. And because our base is 1 minus x squared, we can't classify this as a power function. Instead, we'll classify it as an algebraic function. And algebraic functions are those that take a polynomial and construct the function using only addition, subtraction, multiplication, division, and taking square roots. And as you can see, we've started with this polynomial, and all we've done to it is take its square root, which is why we can classify this as an algebraic function. For our third function, h of x, you can see that we have individual power functions. X to the 9th is a power function, and x to the 4th is a power function. But when we add them together, they become a polynomial function. X to the 9th plus x to the 4th will be a polynomial function because our exponents here are non-negative integers. However, if we really want to be thorough, we should go ahead and call this a 9th degree polynomial because the largest exponent is 9, which makes this a 9th degree polynomial. For r of x, you can see that we have a couple power functions, x squared and x cubed. Even x to the 1st here are power functions. You can also see that we have a polynomial function in our numerator and a polynomial function in our denominator. But when we put this all together, we know that we have a rational function because a rational function is just a ratio or a fraction of two polynomials. So whenever you see a polynomial in your numerator and a polynomial in your denominator, you know that you have a rational function. The last two, I think, are a little easier than the first four that we've done. Whenever we see tangent, sine, cosine, any of our trigonometric identities, we know right away that we're dealing with a trigonometric function. Trigonometric functions are part of the family of transcendental functions, but obviously we want to be as specific as we can here and call this a trigonometric function. Similarly here for our function t of x, we know that we have a logarithmic function because we see that we have log base 10. Whenever you see log or ln for natural log, you know that you have a logarithmic function. And again, logarithmic functions are part of the transcendental family of functions. But as always, we want to be as specific as we can and call it a logarithmic function, which is more specific than calling it a transcendental function. And that's it. That's a basic overview for how to classify functions.